Pleasant day, everyone. I am Micah Andiva, along with my co-researchers, presenting our topic entitled Viability of Tannia, Santosoma sangitifolium Pill-based Starch Bioplastics as substitutes to conventional plastic straws. And without further ado, let's start. According to a study written by Ritchie et al. 2018, plastic waste is a significant environmental issue causing significant damage to ecosystems, people's health, and the global economy. Natarahan et al. Highlighted the need to find viable alternatives to conventional plastics. One of them being bioplastic, a biodegradable plastic that breaks down in the environment. Starch is one of the most widely used materials for bioplastic and is abundant in plants like potatoes and cassava. In a study conducted by Katakis et al. Compared to cassava and potato starch, starch derived from taro, it is the most suitable for bioplastic production due to its high tensile strength and low water absorption. Unfortunately, taro is not always available near the research locale of the study, resulting in the researchers deciding to choose Tannia instead, a close relative of taro. Moreover, plastic utensils like plastic straws are one of the contributors of plastic pollution. By exploring the potential of bioplastics derived from the waste of Tannia, this research highlights the feasibility of eco-friendly alternatives in various applications, specifically for straws.
The purpose of this research was to assess the viability of using Tannia pill-based starch bioplastic for straw production as an alternative to conventional plastic straws. For the SOP 1 to 4, the researchers aim to determine the maintenance strength, water resistance, longevity, and biodegradability of Tannia pill-based bioplastic straw in varying amounts of Tannia pill starch, specifically 0 grams, 15 grams, 30 grams, and 45 grams. Moreover, for SOP 5 to 8, the researchers aim to determine if there's a significant difference between tensile strength, water resistance, longevity, and biodegradability of the bioplastic straw with regards to the amount of Tannia pill starch. These were the hypotheses that researchers formulated. In the null hypothesis, there was no significant difference between the tensile strength, water resistance, longevity, and biodegradability of Tannia pill-based starch bioplastic straw in varying amounts of Tannia starch. And for the alternative hypothesis, there was a significant difference between the tensile strength, water resistance, longevity, and biodegradability of Tannia pill-based starch bioplastic straw in varying amounts of Tannia starch.
Good day everyone, so now we'll discuss our methodology. Gathering of materials. The 9 kg of Tannia were obtained from Commonwealth Market and consumed by the researchers for personal use. The pills were collected afterward. Additionally, materials for the study including glycerol and sodium metabisulfate were purchased from online marketplaces such as Lazada and Shopee. Preparation of Tannia pill starch. The extraction of starch from Tannia pills was based on the procedure outlined by Vitari et al. 2023, with some modifications. The pills were washed, cut, and blended. They were then mixed with distilled water and soaked in sodium metabisulfite to prevent oxidation and microbial growth. After straining, the mixture settled overnight, allowing starch to settle. Removing the supernatant yield starch, which was washed, sun-dried for 48 hours, ground into powder, and sieved. So now let's move on to experimentation. During the experiment, researchers prioritized safety by wearing protective gear and conducting experiments involving chemicals like sodium metabisulfite in a well-ventilated lab. Preparation of control group and experimental group. The control group comprised a bioplastic composite with 15 grams cornstarch, 100 ml distilled water, 10 ml glycerin, and 10 ml vinegar, while the experimental group replaced cornstarch with 15 grams, 30 grams, and 45 grams of Tannia pill starch. Each mixture was heated at 130 degrees Celsius for 15 minutes, then air-dried for 48 hours. After drying, the bioplastic was scraped into straws around chopsticks and solidified using hair iron, following the method in the study conducted by Torres et al.
So for post-experimentation, the gathering of data, the researchers have gathered all the necessary data. This includes the measurements for the straw's tensile strength, its water resistance, its longevity, and its biodegradability. So next is the statistical analysis. So after gathering the required data, the following statistical methods will be used. So for problems 1 to 4, the arithmetic mean will be used to average values for tensile strength, water resistance, longevity, and biodegradability, and also standard deviation will be employed for the raw data. To answer problem numbers 5 to 8, the significant difference in the bioplastic straw's tensile strength, water resistance, longevity, and biodegradability, one-way ANOVA will be used. It involves determining alpha level, degrees of freedom, sum of squares, mean samples, E-value, table F-value, and F-value to make decisions. Once the F-value is obtained, it will be compared with the table F. Moreover, the computed P-value will be compared to the alpha level 0.05 to decide whether to reject the null hypothesis. And if there is significant difference found, the researchers will run Tukey's HSD in order to affirm the findings.
Now let's move on to the result and discussion. For the first SOP, the results provide the tensile strength for each bioplastic straws. Based on the results, straws with 45 grams of Tannia pill starch displayed the highest strength with 0.172 MPa, suggesting a correlation between higher Tannia pill starch concentration and increased durability. Conversely, straws with 15 grams show the lowest strength with 0.025 MPa. For the second SOP, the results for water absorption were provided. According to the results, cornstarch straws had a mean absorption of 35.34%, while Tannia pill starch straws varied based on the amount used. 15-gram cornstarch straw exhibited the lowest absorption, indicating high water resistance, whereas the 45-gram Tannia pill starch straw showed the highest absorption with 54.12%, suggesting lower water resistance. For the third SOP, the longevity or the co-absorption of bioplastic straws were provided. Based on the result, cornstarch straws had a mean absorption of 40.29%, 9%, while Tannia peel starch straws varied based on the amount used. 15-gram Tannia peel starch straws exhibited the lowest absorption with 33.75%, indicating high coat resistance, whereas the 45-gram Tannia peel starch straws showed the highest absorption with 82.66%, suggesting lower coat resistance.
Now, let's look at the results that were gathered to answer problem number 4, which aims to determine the biodegradability of the Tannia peel-based starch bioplastic straws among varying amounts of Tannia starch. First, for the cornstarch-based straws which had 0 grams of Tannia peel starch, they garnered a mean percentage value of 4.52% with a standard deviation of 2.16. Next, for the Tannia starch-based straws which had 15 grams of Tannia peel starch, they garnered a mean percentage value of 5.04% with a standard deviation of 1.36. Next, for the Tannia starch-based straws which had 30 grams of Tannia peel starch, they garnered a mean percentage value of 8.85% with a standard deviation of 2.8. Lastly, for the Tannia starch-based straws which had 45 grams of Tannia peel starch, they garnered a mean percentage value of 7.24% with a standard deviation of 2.64. Now let's look at the results garnered in order to answer SOP number 5. So, SOP number 5 aims to determine whether a significant difference exists between the tensile strength of Tannia peel-based starch bioplastic straws in varying amounts of Tannia peel starch. You can see that the F statistic value is higher than the table F value, which implies that there is a significant difference existing in terms of tensile strength between the varying amounts of Tannia peel-based starch. So the following groups that had significant differences are as follows. So first is the Tannia peel starch 15 grams and 45 grams. Next is the Tannia peel starch 30 grams and 45 grams groups. And lastly is the cornstarch 0 gram group, and the Tannia peel starch 15 gram group. Now let's look at the results gathered under SOP number 6, which aim to determine whether a significant difference exists in terms of water resistance in the varying amounts of taro peel starch between the different setups of taro peel-based bioplastic straws. Referring to the ANOVA table presented, the F statistic value is less than the F table value, which implies that there is no significant difference in terms of water resistance of the Tannia peel-based starch bioplastic spoons in varying amounts of Tannia peel starch. However, it is still worth mentioning that in a study conducted by Balachander and Jayasubramanian in 2016, which stated that more starch content present within a bioplastic will equate to a higher water absorption value due to the increased breakage of bioplastic during the gelatination process of its production. But even though the results of the water-resistant tests show increasing patterns, they were still proven to have no significant difference.
Now let's proceed to SOP 7. Is there a significant difference between the longevity of Tannia peel-based starch bioplastic straw and varying amounts of Tannia peel starch? As shown in the one-way ANOVA test for longevity that the researchers have conducted, the p-value computed is less than the alpha value, and the F statistic value computed is greater than the table F value. This shows that there is a significant difference between the varying amounts of Tannia peel-based starch. In order to find out the specific pairs that has a significant difference, the researchers have conducted a Tukey's HSD test. As shown in the Tukey's HSD test for longevity, there are 4 pairs that has a significant difference. The cornstarch versus Tannia peel starch 30 grams, cornstarch versus Tannia peel starch 45 grams, Tannia peel starch 15 grams versus Tannia peel starch 30 grams, and lastly Tannia peel starch 15 grams versus Tannia peel starch 45 grams. These are all the groups where the p-value computed is less than the alpha value. Proceeding to SOP 8, is there a significant difference in the biodegradability of Tannia peel-based starch bioplastic straw and varying amounts of Tannia peel starch? As shown in the one-way ANOVA test for biodegradability that the researchers have conducted, the p-value computed is greater than the alpha value, and the f-stat value computed is less than the table F value computed. Thus, this shows that there is no significant difference in terms of the varying amounts of Tannia peel-based starch for the biodegradability.
To conclude the results and the findings of the study, I will now discuss the conclusion. So the experiments evaluated the effects of varying amounts of Tannia peel starch on bioplastic properties. Higher amounts generally led to increased tensile strength and biodegradability, but also increased water and coke absorption, reducing liquid resistance. Specifically, the group with 45 grams of Tannia peel starch had the highest tensile strength, while the 15 grams group exhibited the highest water and coke resistance. Additionally, the 30 grams group showed the highest biodegradation. Notably, the absence of Tannia peel starch affected bioplastic qualities. Significant differences were found in tensile strength and longevity among different Tannia starch amounts, while water resistance and biodegradability showed no significant differences. These results closely resembled findings from Gutierrez et al. Study on paper straws, an existing alternative to plastic straw, suggesting Tannia peel starch bioplastic as a promising alternative to conventional plastic straws. Now, to guide future researchers in improving this area of study, I will discuss the conclusion. So, future researchers are encouraged to conduct comprehensive literature reviews to enhance the formulations for better bioplastic quality. It is also recommended that experiments be carried out in specialized laboratories under the supervision of accredited scientists. Additionally, researchers are advised to conduct water resistance tests at various temperatures and explore materials that can enhance the bioplastic's resistance to water. Furthermore, future researchers should conduct the biodegradability test according to the ASTM D5526 guidelines to simulate real-world conditions effectively. By following these recommendations, future researchers will ensure that significant contributions will still be made despite tackling a seemingly overplayed area of thesis.